again, welcome to NRA. This is our quote November team meeting, but we're doing it as a quarterly team meeting. And next slide there, Lauren. And I guess to introduce myself, I'm Ben Worrell, the National Road Research Director. I work for MnDOT. And again, this quarterly theme, Raul really talked about this in some of our team meetings that we get together as chairs and talk about different things and updates and things we could do better. But the idea is to get together so we could kind of have that discussion over all the teams about what's going on and kind of give some direction that way so we could get some synergy between the different teams, because a lot of times things that are being done in one team is for another team, and if you don't get to see that, that's not great. So again, we always have our project pages, our website. Lauren's always trying to get that updated as best she can, but she needs your feedback on that. And that's a good way to find information, but this is another way that we're doing this. So we're going to have these joint team meetings in February. April, we'll be kind of doing it in person, the conference in August and November. So this is kind of our quarterly team. Otherwise, that we'll have our normal team meetings on the other months. So today, really what our agenda is, I'm going to give a quick update on NRA. We'll have the Geotechnical, ICT, Flex, Rigid, and PM teams chairs talk, and they may have some people helping them out. I'm not sure how they're doing it, but they each have 15 minutes, and we'll have a 90-minute meeting, so an hour and a half. Next slide. So one things for my quick update is there's TRV meetings coming. We are sending agency members to that. Lisa Blada sent out some information. If you haven't gotten that or know about it, it was sent to the executive committee. So if you're on a team and not a part of the executive, you may not have seen it. But again, talk to your executive team members for your state. Tell them if you're interested in going to TRB, and then the information there will get you how to do that. And that's working through Lisa Blada and the people at the Maplewood Lab. We have to go through a process for getting travel for you, but you have till November 18th. Then we'll have to put in to set up the arrangements for you. So hopefully you can take advantage of that. We are going to have an NRA meeting Sunday night. I think it's 5:30 to 6:30 at TRB. So kind of block out. I'll send that information out in an email too for you to reserve that time. Get it on your calendars. I don't think we're going to have an online meeting that night because I don't think people want to be working on Sunday nights, but we'll be meeting at TRB, and we'll make the opportunity to go there and learn about all the different things that are going on and bring it back to our group to make improvements and benefits, to provide benefits to our group. We also have the pavement conference coming up in Minnesota, in Minneapolis, St. Paul, and actually it's in Shoreview. And again, sustainability will be the focus. It'll be very similar to what we did before in 2024, but in April 22nd, 23rd of 2025, we'll be looking at sustainability, where the first day we'll have some general sessions and then team-led sessions on sustainability of completed NRA projects. And then day 2, we'll be talking about kind of the team's updates and highlights, with an afternoon Winroad open house demos. And so that'll be part of the payment conference. Another thing that's going on right now is you should have received an email about nominations for the Skoke and Warbach Awards that are tied to the NRA pavement conference. Again, the Skoke is a national award. We'll be having all NRA members provide nominations for that. Nominations are done online. They'll be done basically in November. Then in December, we'll vote. And then also for the Rohrbach Awards, it's the local awards here in Minnesota, where there'll be more the MnDOT people, Minnesota people, cities and counties will be voting on that Rohrbach Award. But both those will be presented at the pavement conference, and you have an email on it. Nominations again in November, then voting in December based off those nominations. Next slide. All right. The other part of NRA that's coming up I was talking about developing a benefits statements for NAA. And I'm not sure if we're going to develop a report for this or if it's going to be marketing materials, but I think it really will serve as justification for, NAA and what we're doing. So I think as states, if your higher ups ask, why are you part of this pooled fund? This will help answer some of those things. And we can use this for a lot of different things, but trying to do is keep it really simple for your feedback. We talked about doing the survey monkeys, this, that, and everything else, but we're looking for individual responses from you. You can sit down as a group if you wanted and do that, but really we're going to be looking for emails. It can be any format, doesn't need to be spelled right, doesn't need to be cute or fancy, but just get us those ideas. We're going to follow up with you on those later on. And hit one more button there, Lauren. And I guess the way we're going to do this for the first initial round is email us by December 20th. And what we're really looking for is general benefits. What I mean by that is I just jotted down some examples there, but it's like how we know know each other better and we can exchange information better by having this pooled fund. So that might be a bullet on that report, or industries included throughout the research efforts, which before they didn't have that avenue. These are maybe on the list. I just threw a couple down, but again, that really helps in implementation, having all the players in one room when you're doing these things. But we're also wanting to look at specific benefits for projects. It may or may not have a cost savings. I won't get too hung up about that. But for one example, is like the early opening of concrete. It seems like that one has really helped us develop different specs than we had before to allow for cars to be on roads before we normally had them before. And so you might be able to say that's a benefit that we learned from NAA with the test sections we built out here at Lowvine Road on Admin Road. But things like that. So there'll be general, then there'll be project specific. And you might see a way to say that, for example, if we were building our concretes thinner, not saying we are, but if you had so much concrete done per year and you saved an inch, what would that cost be? So if you want to take a stab at something like that, you can. The NAA team pages, I think, is a good place to look to. And I think a lot of us have been on TAPS. So go ahead and kind of use your knowledge on that and get that back to us. And we'll start putting that together and start kind of following up with the NAA teams, individuals, and kind of get this into a working document for us to look at. And we're always looking for suggestions for improvement. If you have some ideas for that, we always welcome that. So you'll be getting an email from me coming out in the next couple of days, kind of talking about benefits and how we're going to get this started. Next slide, Lauren. I think that's it for me. All right, well, I'll pass this off to Raul now to talk about the geotechnical projects that are going on through NAA.
Good morning, everyone. Raul Velasquez, Geomechanics Research Engineer at MINDAT. I'm chair of the Geotech. Thank you, Ben. Thank you, Lauren. Try to be as brief as possible. So we completed so far this list of projects. 2017, we have two. One synthesis on large sub-base materials, and then a big project on recycled aggregate base led by Iowa State, Wisconsin, and Michigan State. In 2019, we have a kind of a nice variety of projects. One dealing with drainage, developing of a criteria for selection of granular materials for permeability and drainability purposes, led by Wisconsin, UW Wisconsin. Then we have another one on developing of an app for flooded pavements, led by University of New Hampshire. Another one on improving the input, not improving, but getting a database for material inputs for mechanistic empirical design calculations, and that was led by Michigan State. And then another one on developing some tools to predict freeze-thaw cycles, frost depth. That one also developed, led by Michigan State. In 2020, we have a very interesting project led by UTEP, University of Texas El Paso, on the the development of a device to continuously measure moisture during construction. We have some interesting results. Technology is still not not ready for deployment. They utilize the concept of complex resistivity and found some interesting trends, but it's not ready for moving forward with that project. So that's kind of a summary for completed projects. If we go next, please. So I wanted to show you this in the context of an infrastructure asset lifecycle, what we have accomplished thus far since we started this pool fund in terms of the geotechnical team and the geotechnical deliverables. So we go into so I'm trying to map the outcomes and the results from the research completed so far in this life cycle asset. So if we go into the design, we have completed and is ready available for state DOTs and practitioners to use. Some nice guidelines for the use of recycled aggregate bases. We have a very nice database that practitioners and researchers can use for MEPDG analysis of recycled aggregate-based materials. And that one mostly focused on mechanical properties like stiffness, resilient modulus, strength, and Poisson's ratio. So if you are doing sensitivity analysis of certain recycled materials, you can use that database that was developed by Deliver, summarized very nicely in that research project. We have also developed and improved criteria for selection of materials for drainability purposes in the context of unsaturated soil mechanics. So that was pretty nice. That was, again, led by University of Wisconsin-Madison. That project won an award at TRB for best paper of the geotech section, I believe. And it's very simple criteria that you can use. You get your gradation of your material and some additional parameters if you have available to select, in terms of drainability, if it's okay or not to use that material for pavement purposes. In the construction step, we have worked on suggestions to improve RCA and RAP specifications for, again, pavement foundation purposes. We identify some issues with the use of a large stone subbase and some strategies to mitigate those issues, mostly related to migration of subgrade soil into that large stone subbase. Then we also evaluated, as I mentioned, the complex resistivity as a method to evaluate continuously the moisture. I think there is a lot of promises on that, but still we have to probably do a lot more work and invest more if we want to go that route to use complex resistivity to assess moisture in soil and groundwater material. And also very important, but I think probably Kyle's going to talk more about it. We investigated and spent a lot on the importance of uniformity for pavement foundations, and what I mean, aka IC compaction, intelligent compaction for pavement foundations. So we provided some support to the ICT team in some of their efforts, but internally too, we have done some work on IC in Mean Road, supporting some of these projects that I'm highlighting here, the importance of intelligent compaction, uniformity on pavement foundations. In the step of maintenance and operations, we have worked on developing an app and a program to assess the performance of flooded pavements and when is the right time to open it up again for traffic. We have a phase one. We have a nice product, but we started another project to improve that app and to validate it. So that's still work in progress, although there is a tool available right now for use. And also for maintenance and operations, we have this tool to predict freeze-thaw, freeze-thaw cycles, frost depth penetration, and temperature profile across the pavement. So that's kind of for the completed projects. Can we go next to the current projects, please? I'm sorry, I forgot this one. And this one, we have these tools available. So right now you can go and access this information and you can add this to your toolbox, engineering toolbox. So we have this app that you can use for assessing the quality of your pavement after and before flooding. And you have a screenshot of the current version that we have available after phase one of this project. Team is going to provide an update and they are developing to have a new GUI improved version of it, but you have this version available if you want to use it. We have also developed a tool in Excel and in Python, Excel for small data sets and Python for large data sets to predict temperatures and number of freeze-thaw cycles and duration of freeze-thaw cycles for planning purposes and for estimating performance of your pavement foundation purposes. You also have this nice unsaturated framework to assess if your material is good in terms of drainability or not. Very straightforward, very simple, very nicely developed by UW, Wisconsin. And then I think this is very nice. Also, the databases. We have two databases available in the project website for properties for RCA and RAP for payment foundation purposes. So these are the 4 tools that we have developed so far that you can easily access and start using. Next, please. And now we're going to briefly update of current projects. I'm hoping that our PIs are available or the students working on these projects to have a brief update, provide a brief update to NRA as a whole. Bora, are you online to talk about the Week in Geotextile project?
Hi, Raul. Yes, I'm here. Do you hear me okay?
Yes.
Okay, thank you, Raul. So this is a kind of large project, and we got an extension on this. We work with Dr. Pupala from Texas A&M and Dr. White from Ingeos Geotechnics. The main goal of the project was try to understand both short-term and long-term properties of using Viking Geotextile in payment foundation systems. And the main idea is to check to see if Viking Geotextiles are removing the moisture out of the payment systems, which moisture is one of the most damaging phenomenon or parameter that impacts the payments performances. So we wanted to check to see if that works properly in the short term and long term. The two main performance evaluation of this project is we have conducted very large scale testing, one with Ingeos facility and one at Texas A&M, and monitoring the test sites last 2.5 years, and it will be third year this coming spring to check to see how the moisture regimes changing along with the temperature regimes, and also FWD test data in terms from the mechanical perspective. We hope to submit the task 7 by end of this month, which is the interim report for the second year performance evaluation of these test sites. And task 5 is the long-term field monitoring. It will be available. We plan to submit it after the next spring thaw, sometime in April or May time frame. So.
Thank you, Bora. And you want to mention about the time extension that we last year we have a very mild freestyle season, and we wanted to push these sections to the limit, and therefore we requested for a year extension, right? That you got approved by NRA.
Yes, yeah. Maybe I forgot to mention. Yes, we asked NRA to extend it for additional year, and we really appreciate their their help on extending that. So we can really get a good monitoring season hopefully this year. So we're begging for harsh winter this year. So I know many Minnesotans don't want it, but we hope that we get that harsh winter this year. Thank you again
Hopefully,
for the second.
Yeah, hopefully we have a tough winter at Minro this year, so we can push this technology to the limit. Thank you, Bora. Majid, I think you're on the line. Would you like to get an update on your project?
Yes. Hello, everyone. Good morning, and thanks, Raul. Yeah. So as Raul mentioned, the first phase of the app, and actually the app is on the website, and you can you can get to the link through the NRA website, and it's a MATLAB based. The new app is in Python based, and it's much simpler to run and basically download, install everything. Computationally is more efficient, and a lot of more different, features. So the development of the app phase part of the task, that part is almost completed. So basically, a beta version, probably we can release it soon. Although there were different validation component, like experimental validation, numerical validation, and field validation. So we had some challenges with the experimental tests that we were developing and running. So that delayed us a little bit. So the validation, and also we are looking into some field data, working with Raul and Ben. But the app, we made a good progress on the app itself, on the basically the software. So, and hopefully soon, maybe sometimes end of this year or very early next year, we release the beta version, so people can use it while we run through the validation and basically completing the project. So depending on the field data we get, we may need another extension. We already got the one extension because, as I said, the experimental parts delayed us, but also we are getting really good results on the experimental, which is like a physical model of loading the soil system under dynamic loading. So with a saturated condition, which is like flooded model and different water levels. So there are good data there just by itself. But the app part, we have made good progress.
Thank you, Majid. Yes, I highly recommend you guys to download and start using the app. It's very useful and very powerful. They use this dynamic systems framework, very useful tool for planning purposes. And one of the benefits, as Ben mentioned about NRRA, is this collaboration. And we are looking, as Majid mentioned, verification and validation sites, sections that we can use to validate how good this app is. So if you have any section that is instrumented, or a section that floods continuously or regularly in your network, and you have some sort of information, either FWD or even visual inspections that you use, it will be very helpful for us. This NRA has helped us a lot. An example is that past few weeks, we have been exchanging emails with Auburn University and CAT. I think, what's the name of the professor, Majid? Do you remember? Ben Wowers?
Yeah.
He's trying to help us out with some of his sections. So
Wowers.
this is kind of shows that this alliance can help us out meet some goals.
So they have a FHWA project, and they have some data on the moisture, conditions and things like that. But they may do some FWD. But if anybody or any agency has or they know data exists, I would really appreciate it. It helps to improve the app.
Thank you, Majid, very much. Next one, the water repellency project. I don't know if Bora or UNCC. Okay, Bora.
Hi, Raul. John wasn't sure if he could make it. So this is a collaborative project with Dr. Downs from University of North Carolina, Charlotte. And this is an add-on project on this technology, via engineering, making the soil water repellent and create that water repellent barrier deep in the pavement foundation, so it doesn't allow especially the groundwater table to rise up to the pavement systems, so minimize that again moisture damage, especially in the freezing and thawing sections, and also wetting and drying sections. So this is an add-on on our previously completed projects funded by National Science Foundation and Iowa Highway Research Board, where we have done comprehensive laboratory analysis. And this project, two main focus is really building a actual test site, and we build a test site on Min Road, and then develop some sort of numerical modeling framework and check to see how predict its future performances. So it had a lot of field work. Actually, we had to build the test section twice, thanks to Min Road and Minnesota DOT personnel on this. We really appreciate it. And things are going well so far. And just like the first project that I mentioned, we really beg for harsh winter this year too, to check to see the efficiency and performance of this test site in Min Road too. So.
Thank you, Bora. Next one is kind of relatively new technology, measuring while drilling for geotechnical subsurface exploration. I think the professor leading this work has a conflict.
I'm here representing him.
Yeah, there you go. Thank you.
I'm his grad student, and then he's busy, so I'm just representing him for today.
Thank you. Can you provide an update on the project?
Yes. So basically, the first task about instrumentation and literature review has been done and submitted, and has been accepted. And then with the second side of it, the data collection is still ongoing. And then we have about data for about 10 boreholes that we are working on, and they are still collecting more. And then we have like the development of our GIS web-based map. That is the framework is done, and then since it's tied to the data collection, it's still ongoing because you have to upload the data to the GIS web map. And the pre-processing of the data into spatial database, we have a couple of Python codes and trying to, as much as possible, automate the process because of large data, and then it's still ongoing. And for tax 5 and tax 6, we are yet to start with that because they are also tied into the completion of the data collection.
Thank you, Michael. Nice to meet you.
Nice to meet you too.
Thank you, everyone. And then next one, very quickly, I think I'm over 2 minutes over my time. You can move the next slide, Lauren. So again, mapping again into this asset life cycle. Green ones that we completed, ongoing projects, this is where it falls into. So we have invested a lot now working on water management, as Bora mentioned, Wiki Geotextile and the water repellency technologies. We're working on improving and validating that flooded payment app in the maintenance operation step. And I'm very excited about it. Federal Highway is pushing very hard on this technology too. It's measuring while drilling in the planning design stage. I think this technology can help us improve the efficiency of how we explore, how do we complete these boreholes, and also the information, how can we connect that to design directly. So I think there is a lot of momentum at the national level for using this technology for geotech exploration. And with that, I'll give it next to the next person in line. I think is Kyle. Sorry if I took a few more time than it's assigned.
All right, thank you, Raul. So I'm going to give ICT related update here, and just mention quickly that I'm excited about doing these kind of more full group updates, because I think especially for our ICT group, it's great to be able to meet together, but really we want our stuff to be used by the bituminous group, the concrete group, the geotech group. So it's good to be able to share kind of the highlights of what's going on with our group with you guys, to hopefully get some feedback and make sure you're aware of some of the tools and methods that are being developed that hopefully can be applied for you guys. And with that, I did want to highlight, I know George Chang gave a research pays off update, but I was pretty thrilled with the conference at the ISIC to be able to get a bunch of people working on intelligent construction technologies together, and just mention it here to the larger group that hopefully we can continue to build on that for the next conference. Next slide, please.
Hey, Kyle, real quick.
Yeah.
Sorry to interrupt.
Please.
If anybody has any suggestions on how we can improve, I don't think there's any of the other officers on today, to improve the next conference. I know there's discussions about having that annually now. So please give it some thought, and if you can shed some light on some things we could add, that would be greatly appreciated. I think I can speak with I think I can speak for everyone on that. So I thought it was a great conference too, by the way. So thank you.
Definitely. Yeah, and I think a big part of that is we do have active industry and partners who are all kind of working together to try to get this stuff to help us build better pavements. So yeah, please email me or Jim or Lauren or anybody if you have any suggestions. We're always looking to improve. A couple other related events to intelligent construction technologies that happened just recently here. We have a couple pooled funds that we're leading at MnDOT, one for continuous bituminous pavement stripping assessment using NDE technologies. And I know through that event, there was a lot of good dialogue in addition to the project updates and things in terms of what types of tools and software and analysis are kind of the highest priority for doing project scoping and things of that nature. We're also leading a density profiling system pooled fund that recently met. And I guess one thing I wanted to highlight there that might be of interest to the group is that generally speaking, I've kind of been pumping the brakes in terms of whether or not this stuff is ready for prime time, primarily due to a need to be able to collect the data safely and without putting too much of a burden on the people who are going to actually have to collect this density profiling data, and then also being able to actually use that dielectric information to give useful results to the districts and end users and road owners without having to do a ton of calibration and things that kind of make it infeasible. And the reason I bring that up is that there has been a huge advancement, not just with our methods that we're using to analyze the data, but industry and the vendors have really stepped up. And we have some of the forms of data collection that you see on the lower left there with the technology that used to be unavailable to us. And long story short, I think we're at a point where we're going to start putting this stuff on projects, and we're going to use it to improve our consistency of our density out there. So certainly, I think that's of huge interest to a lot of states, and we've got a large group of states joining us, and some good ideas on how we're going to get this stuff implemented. That's kind of the focus of our next phase of this pooled fund, to really start using this technology to build more consistent density. So please contact me if you have any interest in learning more about that. Next slide, please. Yeah, just wanted to list this here if in case Lauren's going to distribute. I'm not going to go through all the details of these projects that have been completed. One of them dealt with what Raul had mentioned with consistency of our foundation and base layers, which was a nice project. Next slide, please. And currently, there's a couple projects we're working on. One dealing with effective use of traffic speed deflectometer. Another one we're working with the concrete group on, or at least supporting them. This is a concrete project primarily for the rigid team that we're co-sponsoring for automated 3D GPR analysis. And then the one I kind of wanted to spend our remaining time highlighting was establishing applicability of NDT methods for project level evaluation. This is really good timing for us because we want to get a good TAP together. You see some of them listed here, and also we wanted to start getting feedback on what are some of the most important things related to this project that the group sees. So Jacob Walker from Georgia is actually leading the charge on this one as our TL, and I don't know if there's anything you wanted to add about this project before we let Sahil take it away.
Yeah, I'll just add real quick, Kyle. I mean, it's a really great project. I think there's a lot of benefits going to come from it, and really excited to see the outcomes from it. And also we'll be looking to expand our TAP as well. And so looking for anybody willing and eager to be part of the group on this. But it's an exciting project.
All right, thanks, Jacob. So, and thanks for stepping up. He's doing a really good job of leading the charge, as I said, here on that project. So with that, I'll let you take it away, Sahil.
Okay, good morning, good afternoon, everybody. Yeah, as Kyle said, this is a very timely meeting because we are doing things so that we can make the life of other groups better in the ICT. So this is one of the projects. It's in effect started last Monday. So after a year of delay with the paperwork from both bureaucracies. So we are very excited about this. And basically our goal is to establish the usefulness and the probability of success of detecting defects for the traditional and new methodologies as a pre-design tool. And the other one is to provide guidelines to engineers to decide which NDT device to use, when and how, to get the more bang in the buck. We are all having a lot of experience with NDT, but there are challenges and there are good days and bad days. can we maximize the good days and minimize the bad days, and don't send the same tool for different applications that may not apply. So that's a goal of the project that we're working on. We have two objectives. One in what are the capabilities and sensitivity of these different methods to the different types of defects, and the other one is the accuracy of prediction. Can we go run an FWD, get the deflection basins, do a back calculation, predict the stresses and strains, and see how good we are doing that, given the uncertainty in the process. So to answer the first one, the objective one, we're going to install some defects within the construction. That will be on purpose. We're going to not put it on the critical places so that it just generates a pothole or cause trouble for MnDOT, but it's going to be at the areas that it will be hopefully not less traffic, and we're going to see what we're going to do. An example of that is the test sections that EOB just put down for stripping, and different sizes, different shapes, different depths, and we can see how well we can deploy different NDTs and see how well we can do with them. Next one. I'm just trying to be as fast as I can, Kyle. I hope I'm not.
You're doing great.
Okay, thank you. The second one, I told you accuracy of prediction, how well we can do the stresses and strain calculations. So basically what we're going to do, there are a lot of really nice sensors at Main Road. We're going to just utilize them. We're going to run different non-destructive testing on top of them, get the responses, and as I told you, we're going to analyze it and then compare with what the sensors say versus what our analytical methods do, given that there is a processing of the data is involved. Next one. So this is, and I told you literally we started on November 1st, and there are 7 tasks. I would like to focus on task 2 today, and then hopefully in the 3 months we can give you more information about task 3 if there is an opportunity. That one is basically forming a technical advisory panel and just basically forming the direction of the project, because there are so many different tools, so many different defects, and so little time before I retire. So we have to focus things a little bit. So let's go to the next one. Next slide, please. So task 2, one back. Task 2 is, I guess, forming a management team and a technical advisory panel. You saw a list of really highly qualified, nice people from both sides. So the first thing, and again, I highlighted over here, we have put a questionnaire together with the help of Jacob and Kyle, and we would like to widely distribute this and try to see what are the impressions that people have. What NDTs are of interest, so that we can focus on the top 3 or top 4. What type of defects, what type of uncertainties are there to address that is of most interest, bang for the buck. And for that one, we need your help. And we need 2 groups of people. We need experts in NDT for sure. And we have a bunch of them on the panel, and we can use more. And more importantly, we need the expertise from the 4 other groups that you are here, the flexible, the rigid, and the maintenance, and people like that. What are you interested to learn more about NDT as a user? And that's what we want to do. We're going to very quickly, hopefully by the end of this week, we're going to distribute the questionnaire as broadly as we can. I see there are 106 of you. Probably all of you would get it and more. And then please distribute it amongst your friends that you think that would help us. And then based on that, we're going to expand the tab. And then we start having a kickoff meeting and start working on the other tasks to just basically optimize the use of the NDTs and understand what the limitations are. If there are any questions, please let me know.
All right. Yeah, thanks a lot, Sahil. And you know, if you even just put it in the chat, if you're interested on being on the tap for that project, or learning more about some of the other events and groups that ICT is involved in, you could do that, or email, as I said before. I guess I am kind of rethinking my involvement in this NRA stuff, because I'm hearing we're giving money to these professors, and one of them wants us to have harsh winters. And now Sahil, we're giving him money, and he wants to put defects in our roads. So I'm kind of not so sure about this, but I guess we'll figure it out here. It just doesn't seem right. But anyway, I think
You pay us to be impractical.
that's right.
You pay us to be impractical.
That's right.
Yes.
That's right. So I think the flexible team is up next.
Okay, sounds good. Is there a couple slides before that, Lauren?
Nope, this is what I had.
Yeah, there's a few more, but I've got if I could share I've got it up. I mean, we could share my screen, I guess.
Well, we've got this, and then
There was
a
like
bunch of
3 other
pictures
before
after,
that.
but they were all after.
Oh. Yeah. Oh, okay. Okay. Okay, we can just go with that. So thank you, everyone, for participating in the meeting today, and thank you, Ben and Lauren here. And it's I think first time we've all really been together, I think, since the spring conference. So as everybody is mentioning beforehand, it's really nice to all get together more frequently now, where we can see what everybody else is doing and stuff. So we've got, I think, for the kind of a brief outline of what we're going to do here, I'm going to go over the updates of all the projects very briefly here, and then we're going to have a highlight one of the projects here, which is reflective cracking study. And so Michael Burtis and from Menroad here, and Isham from, or I should say Misham from UNH will be giving a couple presentations on the reflective cracking study. So I can start out here. And so before I do, though, I'd like to thank all the Flexible team for their hard work throughout the year. I think we had a lot of progress, and we had a lot of really good monthly meetings as well. And we're continuing to bring forth really good ideas that we turn into sound practical research that we can, once they're completed, we can take it back to the agencies to implement. So starting with that, then, so we've got ongoing projects here. We've got about 22 listed on the website, and several of them here: reflective cracking challenge, which we'll hear about later, milling, reclamation and recycling techniques. 75% is done now on that project. Field validation of using warm mix asphalt at reduced production temperatures is just getting going here with task 1, and then we have a standardization of SIP calculation is in the task 1 stage as well. So next slide, Lauren. So then we've got some developing projects coming up, coming around here too. 2 of them, recycled binder availability and perpetual pavement test sections in wet freeze climates, are the RPs are being developed so that they can be posted here. And then we've have 2 more that mixed rejuvenator test sections and continued monitoring of the original I-94 sections are past the contracting now, but you're just starting to get going here. So next slide, Lauren. Should be a complete. There's maybe a couple slides that maybe didn't get in there, but there was some completed sections that we have, and there's about 8 of those. And anyway, those are ones that that it would be good now that we have the completed sections here that we can start to implement and take some of this research back now and try to implement into our agencies, into our highway programs and stuff. So next slide. Okay, that's it. Okay, so maybe go back to this one. Okay, so I think from here we're going to yeah, this one here, Lauren. I think we'll hear from Michael now. Michael's going to talk about the reflective cracking study and the some of the testing, field testing performance that we've had so far. So if you'd like to go ahead, Michael.
Yes. Good afternoon and good morning, everyone, depending on where you are. Kurt, really nice job adapting and doing this on your feet when you're missing 4 or 5 slides in the slide deck. I'm going to put the link to our NRA flexible team page that has the link to all of our projects, which is what we used. And the portion that we didn't cover was our kind of historical and completed project portion. Didn't make it in the slides today. So as Kurt mentioned, we're going to be focusing from the NRA flexible team on our reflective cracking challenge sections. Just giving a brief background here, I'm going to talk for 2 or 3 minutes, and then we're going to turn it over to the University of New Hampshire team to talk about the laboratory testing. So these are mainline test sections at Minroad. There's 10 different test sections. They're a total of 400 feet. And then half of the test section, we have underlying transverse saw cuts in the lower asphalt lifts. And then it is the top surface is 2 inches, and that is a unique mix. Next slide, please. Lauren, will you click through all the animations and then back to the end? So those 10 mixes that we have in there feature 3 different binder grades, most notably being a 49-34, so a very soft, unmodified binder. And then we also have 2 different types of recycled plastic and recycled rubber, and then 2 aramid fibered sections, and then a MnDOT SuperPave 5 section. Next slide, please. Quick performance update. There currently is no cracks, so none of the cracks have reflected through any of our surface mixes. We have very good ride and consistent ride over time, and then very minimal rutting even in the soft binder section. All of our sections have under 5 millimeters of rutting, or about 1/4 of an inch. And then a couple caveats with that. As we've mentioned already in this meeting, we've had a very mild winter that these sections are under. And then we've been doing a lot of reconstruction at Minroad, so traffic has been off in some of the summer months while we were building concrete sections down the main line. And then also in the past, it's taken a couple years before we see significant low temperature cracking distress in our sections. Next slide, please. And this is just a couple examples of the sections that we're monitoring. So we're taking the same picture in the same location. Mark, bottom of each image, that is a GPS location of the underlying saw cut underneath. So we're trying to capture that as it reflects through. Next slide. Next slide. Just more examples of the same. And then just to wrap it up, since Dr. Chetin requested a cold winter here in Minnesota, I'm going to have to agree with him. We're starting to get to the point in our reflective cracking challenge experiment that it's getting awkward that we don't have any low temperature cracking in Minnesota. So just because he requested it, let's get a nice cold, severe winter. Now I'm going to turn it over to Dr. Dave and Misam from the University of New Hampshire to give us a laboratory update and tell us which one of those 10 sections is going to crack first.
Thank you very much, Michael. And Lauren, if it's okay, I'll just share my screen just to get, yeah, thank you so much. and you should all be able to see the slides. Let me know if you cannot see the slides. And Kyle, I'm sorry, but I'm with the other. I'm part of that group of faculty that you said that you're paying money to have a cold winter. I'm part of that as well, and seems Michael is on board with it. So anyhow, this the plan here is to just go through it very quickly. One thing I will note is this is not just effort of University of New Hampshire. It's actually a partnership between us, Auburn University, NCAT, as well as Heritage Research Group. So we should have put logos and names of everyone. But this presentation, we are just talking about stuff that are done within the UNH part of the contract. So the idea with the presentation today is just to very quickly go through, give you some snippets of what we have learned so far, and that's what we're limited to. So the objective is just to tell you about the lab testing of these mixes that Michael presented. Just as a refresher, we'll, for today's presentation, focus on the complex modulus testing and the fatigue testing, which are all part of the task 2 of this project. And if you recall from the project, all testing is done in 2 aging conditions, reheated mixes, as well as aged mixes following the critical aging procedure with 6 hours of aging at 135 C. And then quickly, I'll recap things that we are working on right now. So complex modulus, just to make sure that we all are on same page. This is all done following the AASHTO TP132 test procedure. So 3 test temperatures, multiple test frequencies. And what we get out of this test is what we commonly call dynamic modulus, which is the stiffness of your material that shows how it changes at different temperatures and frequencies. And what you are seeing here is a master curve that's already adjusted based on temperatures. And then also we get to see the phase angle, which is important because it tells us how quickly or how slowly this material will relax stresses. So obviously we have this characterization, which is very helpful for doing things like pavement ME analysis or any other mechanistic analysis. But also as a mix designer, as a mix evaluator, you want to know an index parameter that can tell you about how well or poorly this mix may behave in terms of cracking resistance. So for that, we turn to using a parameter called Glover-Rowe mix parameter. You are probably all familiar with Glover-Rowe binder parameter. Same thing here, except it's evaluated with complex modulus of mixes. And typically, we want a lower value for this parameter to have good cracking resistance. So in addition to this, we have also done the cyclic fatigue evaluation using the direct tension cyclic fatigue test, which is also AASHTO specified test. It's a controlled actuator displacement test procedure run on the same AMPT device as complex modulus. And just a quick refresher on it. So every cycle you are doing a fixed actuator displacement, but what you actually use is the strain measurement on your specimen as that specimen is tortured with repeated tensile cycles. And also you look at what kind of resistance that specimen is generating. And obviously as it degrades, its resistance capacity drops. Once again, it generates a wide swath of data from this test that can be used in performance models. For today's presentation, we'll just focus on an index parameter that Federal Highways has really developed and is recommending for evaluating fatigue performance of your mixes, called the damage capacity or SAP parameter. And there's also some agencies that have started to implement this as part of their balanced mix design type of approaches. So just looking at that index from complex modulus, we are looking at the Glover-Rowe mix parameter. Once again, remember, lower value is good for cracking. So you can right away see that all of those mixes with different type of additives from additive group, they're actually all looking fairly good compared to your control, which is just a straight up 58 minus 28 mixture. Even SuperPave 5, which does use a modified binder and has SuperPave 5 attributes, they are all looking better. Typically, we plot this parameter on log scale. We did not, because if we did, you cannot really see the intricacies or differences between all of these treated mixtures as compared to controlled mixture. Other thing we note is, as expected, as we age these mixtures, they all get poorer in cracking resistance, except the difference is that some of these age not so well. So if you look at two examples here, the Super Pay 5 and also the dry plastic, it seems to have a little bit more aging susceptibility as compared to other mixtures. So the main message is that what we are seeing here is that all of these additive group mixtures are almost comparable, which doesn't surprise me because they were all designed using balanced mix design. On the fatigue side of things, so we are looking at that index parameter, and the dashed lines are really representing the limits that Federal Highways is recommending. They're using MSCR type of system, so these mixtures would fall under this high category with 10 to 30 million ESL type of design requirements. So you can see that once again, most of the additive group experiment mixes meet that. Some of the other ones, like the ones that use a more modified binder, you can see where they sit, but also you see some unusual trends where the number actually gets better with aging. That's not entirely unusual because S apparent takes into account combination of your fatigue resistance versus also how stiff your mixture gets with aging, because that improved stiffness or improved modulus is actually helpful because you will see less strains in actual pavement. So again, big picture wise, not too much of difference between all of these mixtures. Control definitely inferior. So to answer your question, Michael, I'm hoping that at least this winter we'll start to see some cracking in the control section as opposed to some of these other sections. Other sections we'll have to see how things pan out. Now keep in mind, there's just 2 of the 7 different type of tests that we are going to be seeing on these mixes. We have already started or had a jump start on task 5 of this project, which deals with modeling of performance. And while we have not started to do more reflective cracking modeling, as you saw in Michael's presentation, half of these sections are more traditional flexible, so we can do a flex pave analysis, which is again a system developed or right now promoted by Federal Highways to predict fatigue performance. And this is just an example of how it's set up. It's all based on Excel-based system now, so very easy to run. Anyone can adopt its usage. What comes out of this analysis is essentially what type of fatigue damage you can expect after certain levels of traffic. And this again a sample result. We also did some of this analysis where we treated that lower layer not just as an intact new layer, but in some cases treated it as like an old layer that may already have some cracking. It's again, this system is not developed for reflective cracking, but we are trying to at least see what all we can learn from it. So here you can, the advantage of doing this is it combines everything. It combines your fatigue resistance of mix, but also what kind of stiffness that mix has, and also what kind of temperature sensitivities it may have, because it actually simulates different seasons or different type of temperature conditions. So far, nothing really jumped in terms of one that will have a high damage compared to low damage. As expected, you can see slightly high bottom of fatigue damage on control section, but time will tell us as to what we are going to see in the end, especially as the field data also starts to come in. So then the very last slide here is just talking about what's next. So we still have quite a bit of lab testing effort. We are here at UNH. We are right now doing the UTSST and DCT testing to wrap those low temperature properties. But also this being NRRA, Illinois DOT is conducting IFIT testing for us, and they expect that to be done by May next year. And then we need to have some discussion both with MnDOT and Wisconsin DOT to get the ideal CT and Hamburg results as well. We do have some ideal CT results because NCAT also tested it for additive group, but not for every mix, just for the additive group mixes. So we need to fill that set. And then also Missouri Center for Transportation Innovation supposed to do TSR and ideal RT testing. So hopefully we can get all of that data by early to late spring next year to be able to do the comparisons, and hopefully by that time we'll also start to see some cracking. And then all of those properties continue to go into performance modeling as well. So that's just a very quick summary on this project, and we are also excited that the I-94 westbound is kicking in, because that will supplement data that we have with this experiment. So Michael, I'll stop sharing here, and then if anyone has any questions, we will try to answer those.
Any questions for Ishan or Michael? Okay, thank you very much for those two wonderful presentations, Ishan and Michael. That was great.
Thanks,
I just
Ben.
wanted to say one more thing before we turn it over. In November 19th, the Research Pays Off, Ishan will be discussing the research project and innovative practical approach assessing bitumen capability or compatibility as a means of material specification. So please join us for that.
Thanks for the plug, Kurt. Yeah, thank you.
Okay, I think with that, I think we'll turn it over to the next team here. So thank you.
All right. Good morning and afternoon, everyone. This is Tom Burnham with MnDOT, finishing out my role as acting manager of the research section, in addition to being the Rigid Team chair, in addition to chairing the 13th International Conference for Concrete Pavement. So it's been needless to say, a very busy summer. So I thank everyone for those that was able to contribute and participate in the conference. It was great, once in a lifetime for our local people to be able to attend that conference. And also crazy busy at Minroad, building 8 new test sections this year, which were kind of a continuation of the efforts in 2022, focusing on low carbon concrete sections. So very busy time for the Rigid team here. We're not going to have any results discussed, but we'll probably follow the style of we're going to introduce the ongoing projects and have people chime in if they want to contribute on where things are at. One of the new sections this summer was involving the incorporation of microspheres as a replacement for entrained air entraining agent. And so that's a study by Iowa State University. They're going to be the PI on that team. They obviously just started since the project just got constructed. I don't know if anyone is on the call that'd like to comment on where they're at, or I don't think I saw anyone from the team was here, and I think even Jacob is not on the call. But anyway, that project has just got constructed successfully and will be starting. The next 3 projects here listed, use of alternative cementitious materials in concrete, use of alternative pozzolanic materials, and also the use of carbon dioxide are three of the projects that are involved with monitoring the sections that got built at Minroad in 2022. And that involved 15 sections plus a control section. And so I'm a TL on the alternative cementitious. You can see they're up to task 4, which essentially they're working on the 2nd year performance report now. And probably most of these projects are in that status. I don't know that we can reveal other than, the sections are performing just fine. They're holding traffic. A lot of them when they were paved were not, some of them didn't look very pretty, and not some, our goal was to get it paved and see if it will survive traffic and the weather. And so far they're doing okay from that aspect. I don't know, does anyone want to, Maria, do you want to comment anything on your project and anything they've told you about significant findings yet, or?
I would say I don't really have any significant findings to share today. Other than what you did mention is we did replace one of the cells that was constructed in 2022 this year during the 2024 construction. So we are down one cell, but we replaced it. So research is still going on. Other than that, nope. I think that I don't know if you're going to talk about what was built this year at all, but I think that's all really interesting, and it's going to be useful for us. So.
Yeah, and one of the things we'd like to point out, we get materials donated for these projects, and just because it didn't work out doesn't mean that it can't be done. It's that sometimes the timing of getting the mix designs in and that type of thing just doesn't work out. And I think that could be the case for that one section that did not work out, is that with a little more tweaking and a little more investigation, I think that mix could be successful. It's just at the time it did not work out. And I think some of these newer materials, these are coming from proprietary, new companies that are new to paving, and they don't quite understand the complexity of putting things through a ready mix plant, through a paver, having to texture it and cure it. It's sometimes a little bit easier to throw it inside of a building form or in a footing or something. So this is kind of a new world to some of these companies, and that's why some of these, they struggle. It's not, it's not that the material is a bad material, but it might not be ready for the concrete paving industry. But that's really what we're about.
Or ever intended for the paving industry.
Yeah.
Some materials will never be practical in that application potentially. So
yeah, and this is where we discover those things. And it's helpful to the company as well that maybe they want to, chase another application than paving. So, Bernard, do you have any comments on what's happening with the carbon dioxide project?
Yes, with the carbon dioxide project, I would want to mention that one of the very interesting aspects was even though it took into cognizance materials from the other studies, but it was based on evaluating the sequestration stoichiometry of the carbon dioxide injection, looking for a way to calculate backwards and find out how much of the carbon dioxide was actually sequestered at source, i.e. at the point of mixing. We did everything possible with the thermogravimetric analysis and also trials at petrographic analysis. Either the experiment or the material did not show, let me say, detectable or highly detectable or highly significant values of sequestered carbon dioxide, which was a little bit confusing to us. But I'm told Iowa State University, who are the PIs, are still looking for alternative methods. Thankfully, we still have some cores. Those are cores that were made from wet sieved concrete in order to minimize the influence of the large aggregates and actually follow closely more of the stoichiometry that's happening in the paste to determine how much of the carbon dioxide was converted to calcite and calculating backwards gravimetrically to find out how much, therefore, was the carbon dioxide sequestered. So that was a significant find, not very encouraging, but at least it gave us some sense of direction. However, we are still investigating, still following the annual, now we have the second year performance report. We are looking at various aspects of the pavement performance to see if we can still pick up any advantage that's inherent in the. We do believe, anyway, that nucleation sites are enhanced when you inject carbon dioxide, and these nucleation sites can allow you reduce your cement. So it's a cement cutback factor among the 4 cells that were built. And we are still monitoring them to see what pavement performance advantages we can still get from them.
All right, thank you. The next 2 projects, the first one is early loading to increase joint deployment. That's really about one of the things we were observing with thin concrete overlays on asphalt was that some of the, we're doing small 6x6 panels, but not all the joints were deploying. So there was some efforts into saying maybe if we load them early, very early in their life, we can get more of those joints to deploy because it's going to behave more like it was designed to. So there was a section put down, and we're monitoring that again. We're at 2 years for that. The one with the diamond grinding, similar thing for thin concrete overlays. Again, can you grind them? Can you repair them? How long does the diamond grinding last until you're back there? And so in addition to some sections that we had at Min Road, we also had some satellite sites in northern Minnesota and also locally here in the metro area. So we've been monitoring those sites. We're actually up to the third year on one of those sites of monitoring to determine how fast it comes back. Unfortunately, all of these sections, well, the sections of Min Road were removed for the new sections this year. So some of these sections have gone away. So that winding down that part of the studies. Next slide, please. Let's see, this was mentioned before, the automated GPR analysis for concrete pavement evaluation. So again, that project is just getting started. I don't know if anyone is online that could comment on where that was at. Unfortunately, Di is not here today, but I believe that project is, again, just started this year. And that's really to help when you're doing 3D GPR over concrete, any kind of analysis with GPR, it can be very tedious. So that the effort is to try to automate that process. And again, that's one of those cross-team efforts that we have with the ICT team. Another project cross-cutting is with the Flex team is this continuing monitoring of the original westbound asphalt overlay sections parallel to Min Road. Those, again, are also very short-term since they're going to be removed in a couple weeks in effort for the new 3 lanes going next to Min Road. So their data collection window is shortly closing on that one. And then finally, this last one is the new project that's similar to the 2022 effort. We have a new contract with UMD to monitor the new sections that were built this year. So that, again, there's 6 new cells built containing different additional low carbon content material or low carbon cement alternative materials in those sections. So just brand new, again, that project's getting started. With that, I think I'll turn it over to the next team. Keep us on time. Thank you.
All right, thanks, Thomas. So if anyone doesn't know me, I'm Tyler Hunt. I'm the Preventive Maintenance Program Engineer for the Michigan DOT. I'm the current chair of the PM team for NRA. I've only got a couple slides, and then I'm going to turn it over to my research groups. I apologize. Some of these, this was an old presentation I sent to Lauren, so it's on me, but this list isn't completely correct, but this is mostly what we have for completed projects of the PM team. And I know I've talked to Ben about this and others about ways we're utilizing NRA research at the DOT level. So I guess being an outside the state of Minnesota, I should say, we're currently having a big push statewide for using ultra thin bonded wearing courses at MDOT. We really like the fixes, and I've had some pushback from some of my local project offices and leadership kind of wondering why. So the 2021 project there with thin layers of preventive maintenance treatment is some of that research I can utilize at the state DOT level to kind of justify why we're going some of these routes. So I just kind of wanted to highlight that there's our spray on rejuvenator test section on Min Roads and our other research has been very useful to me. And so I wanted to highlight this list and just let folks know, I guess, listening in that having this research is really valuable. So can we go to the next slide, Lauren? We have 3 ongoing projects right now, and I believe all my research groups are here. So the use of recycled materials in pavement preservation is a co-research with our flexible team. Adriana, do you have an update you want to give the group on the research?
Yes.
Okay.
Yes. Hi. Good afternoon, everyone. So for the project, we are looking and developing basically a framework for evaluating the feasibility of using different recycled materials into pavement preservation treatments. And those treatments would include chip seals, slurry seals, and microsurfacing. We have completed tasks 1 and 2, which is the literature review and the developing the experimental plan. During those tasks, we identified that there were different materials that people have been looking into as an alternative to replace virgin materials. Mainly wrap is basically the big one and kind of the low-hanging fruit there. But people have also experimented with things like recycled tire rubber or recycled asphalt shingles. To a lesser degree, some other materials like recycled glass or waste concrete, brick, that sort of thing. But based on the existing literature and a survey that we did of the NRA states, we identified that what was more ready for implementation right now was probably wrap and rubber. So we came up with an experimental plan. We're right now in the early stages of the lab testing, starting with 100% wrap designs. We also proposed that we could look into the recycled rubber designs, but we're going to start with wrap and see if the panel would like to do a variation of the wrap designs or continue to look into recycled rubber. So that's where we are right now. We don't have lab results to share, but from what we have seen in previous studies and literature, this can be promising, and we could be looking at treatments that perform just as well as treatments with virgin materials.
Awesome. Thank you, Adriana, for that update. Dan, do you want to provide an update on materials-based methods to improve rubber strip durability? I'm technical liaison with this research group, so I've been pretty involved with the TAP and with Dan, so feel free to take it away.
Yeah, you got it, Tyler. Morning, everybody, or afternoon. So what this project is attempting to do is understand the effect of centerline rumble strips through the lens of pavement performance. You know, a lot of research has been done, obviously, to show rumble strip, how effective they can be for lane departure type crashes and so forth. But comparatively little or less work has been done to understand what effects they have on pavement performance. So we set out with 3 goals, really to document the durability effects of milling in centerline rumble strips and new asphalt pavements. And then in so doing, understand how materials-based methods can help either offset any damage that occurs from milling and rumble strips or prolong the life or any combination of those two, hence the title of this research project. And then to kind of like echo the theme that, you know, Tyler mentioned and Kurt mentioned about, you know, really the value that NRA brings to our industry is how implementable some of this research can be. The last goal is to produce sort of a best practices guideline that helps walk, you know, decision makers, agencies, and so forth through, you know, what the various tools they might have from a materials selection process for centerline rumble strips. So to do this, we built 3 full-scale projects in Wisconsin. These are all rural 2-lane county highways, both for practical reasons. We chose those so that the research team could get out to the site, sample materials, and not be under the stress of you know, highway, you know, interstate type traffic, but also to have more control over changing specifications and so forth for these materials. So these projects are built, they're in service right now. They've been sampled via coring, and it's using road cores to help guide this research. As a sub-study, we wanted to make sure we weren't affecting what we call the functionality of the rumble strip. You know, how well does it work at actually, you know, alerting drivers to lane departure. So we hired a subcontractor to measure noise and vibration effects in our various research cells. 2 different material treatments, and then a combination of those 2 were chosen for durability enhancement. One being a pre-construction material, void reducing membrane, which some of the states on here are familiar with. The second one being a post-construction material, that being an asphalt emulsion fog, and then a combination of the 2. You You can see the extent of my PowerPoint skills here, making a gradient task 3. That task is under review as we speak. So we're making good progress. I believe we've got an update meeting December 18th to present some results to the TAP. So we're chugging along. I will add, as I do in most of my emails, if this topic is attractive to you, excites you in any way, there's always room to join. We've had a couple of TAP members have to drop just via attrition and so forth. So especially if you're an agency member and this is an exciting topic for you, reach out to Tyler, myself, whoever. And I'll add, Lauren did a good job that the website's updated. Any deliverables that have been delivered are there. So have a read if you're interested, but I'll shut up now and turn it back to Tyler.
Thanks for the update, Dan. Yeah, and on that subject, Lauren, I do need to go through, and I think there's some updates that I need to make to the website, or I need to convey to you to make to the website on some of our previous research projects. So that will be forthcoming here, I think, in the next month or so is my plan to work on that. So yeah, thanks a lot, Dan. Appreciate it. That's a great update. Dr. Yu, would you like to give an update on the hot rubber seal coating to survive wet and frozen environments?
Sure.
Potentially some
sure,
slides.
Sure. Thank you, Tyler.
Yeah.
Thank you so much. We probably don't need the slides right now. It's
Okay.
With time being in mind. So the goal of this project, of course, is trying to use the hot rubber seal coat to maintain roads, especially trying to reduce the premature stripping and trying to extend the service life. So there were some really good success in local roads in Michigan. Then we are trying to bring this idea to NWRA. So thank you, many of you got to support this idea. So then what we did was we did a test site in Michigan's M25, and which was a 6.6 miles long stretch. And out of that, 4.6 miles eventually were using hot rubber chip seal. The other about 2 miles we use as emulsion-based as control section. So really we appreciate with MDOT support, to build this project there. Of course, with some support from Bay County Road Commission in Michigan. So especially MDOT, of course, Tyler got a lot, support us a lot. Rob Green really, got the funding to do the construction and all those things. So the construction was completed in July of this year. So I have been visited the site quite a few times. It's really looking really good. The road is really good, and I also prepared a 3 minutes of video clip. It's going to be posted at some point. And so we are actually measuring some of the samples, and as well we get some samples from the cores. We also prepare some samples in-house. We have some testing programs to complete. So right now the work we have done, I think probably like 35% complete. We hope over the winter we are going to get a lot of things done. So with that, I think that's my progress report.
Sounds good. Thank you for that, Dr. Yu. We look forward to see how the M25 project does, and we're keeping a close eye on it internally as well. So sounds good. Before I turn it back over to Ben, I just wanted to say thank you to all my research team and all my PIs and my TAPs. I took over the role as the chair earlier this year, and I was trying to get my feet under me. And the transition, I guess, has just been seamless. And they're really forthcoming with all the information I need and doing the presentation. So just want to say I appreciate you all. And with that, I'm going to turn it back over to Ben or Lauren. Thank you.
Yeah, I'll take it from here. Thanks everyone for your input. Again, this was our first try at doing the quarterly meeting. So I think we'll take this, what we learned here today, bring it back to the chairs. We'll talk a little bit about how we could maybe tweak and improve this. If you have some suggestions, drop me a line. I appreciate that. Also, I think with any of these topics that we have with NWRA, if your agency or your group wants to have kind of meetings about those topics, let us know. I know for NAA in general and things like that, I'm always willing to give a presentation online to anyone. So I think it might be the same for, each of the topics. So if you want to bring it back to your state, just ask. I think a lot of us, just would love to have the opportunity to spend some time with our customers that are going to be using the information. So with that, again, thanks for all your efforts. Thanks for being a part of NAA, and look forward to talking to you guys soon. Take care.